Okay, welcome back. This time we're going just to be talking very quickly about the equation of a straight line. So essentially, this is the form that we're going to be dealing with. Can be arranged in a slightly different way, but this is the one that is the most useful. So in the book, it actually uses y equals ax plus b. Doesn't really matter so we're going to have two numbers in here. We're going to have a y equals something x plus something. I like mx plus c. M stands for the gradient, as we talked about in the previous video. C it's just a number. So I like C because C stands for constant. It's essentially just a constant number. Doesn't matter what value of x we substitute in. This doesn't change. So we've already talked about how this m is the slope. This number on the end, so m is let's call it the gradient. C is this number that we're adding on is, well, it's not what it is, it's what it represents. It represents the y-intercept. And what that means is if we have our axes and we've got a line like that, so the slope talks about for every step we go in the x direction, how far up, rise over run, m. But the y-intercept is essentially, it's that value that the line cuts through the y-axis. This one here is the x-intercept, but we'd have to rearrange the equation a little bit to work that out. So essentially, in linear algebra, all lines can take this form, and we could have another line with the same slope. So they'd essentially be parallel lines. But the thing that would be different is the point that it cuts through the y-intercept. So that would mean this value of m would be the same for both of these lines. But the value of c, this one's up here positive something, this one's down here negative something. So lines with the same slope can cut through the y-axis at different points. And to essentially describe any line, so these ones have a positive slope, we could have a negative slope. There's our y-intercept. So we essentially need these two numbers, m and c, and we'll get examples of these, to essentially describe any particular line in the plane. So the number that is multiplied by the x, and remember we talked about for every one step in the x direction, the line goes up this much. So for every 1, if x is 1, we'd have y being one lot of this plus the point that we started at. One more, so that would be 2 lots of x. We go up 2 lots of the slope plus that point that we started with. hopefully that will make sense as we work through these. I'll just leave that there for a little bit. So there are a few examples here at the bottom of the page, just to sort of explain. So I'll just write these out. Equate 2, y equals negative x plus 4, y equals x, y equals 6. Okay, so this one has a slope of 3, gradient of 3. I should stick with gradient, which means that for every one step in the x direction, it goes up 3, so it's quite steep, and it crosses the y-axis at -2. So the y-intercept would be written as a coordinate like that, but if it just said what is the y-intercept, you could say -2. This line, y equals negative x plus 4, so our slope here, let's just put our sneaky 1 in there, our slope is -1, so that means every step in the x direction the line goes down 1, and it cuts through the y-axis at +4. This line here, the gradient is 5, because it's the number multiplied by the x. So for every one step in the x direction it goes up 5. But we haven't got anything here, and that essentially means it's +0. So the y-intercept, this actually goes through that 0 point. So when we've got no y-intercept written down, it means it goes through the point that the two axes cross. And this is a bit of a weird one. We've got no x term. So essentially, let's just rewrite this out. 6. This is like saying we have a slope of 0. So this is a straight horizontal line that cuts through the y-axis at 6. And it doesn't matter what value of x we come to, we multiply it by 0, it becomes 0, and then we add 6. So every point, every possible value of x is going to take us to that straight line that cuts through the axes at 6. Right, so that's the sort of written examples. Okay, so the next couple of examples, so this is V2.4, is essentially just interpreting equations to work out which is the y-intercept and which is the gradient. So we've got y equals 5x, take away 2, y equals -2x plus 8, y equals 2.5x. So in this one, we've got y equals 5x, take away 2, so our gradient is 5, and our y-intercept, let's not call it c, the y-intercept equals -2. So once you've got the equation, it's very easy just to read these. So notice the gradient doesn't have an x. The gradient isn't 5x, it's the number in front of 5. The number in front of the x. And the y-intercept, if we're taking away 2, it's essentially a negative value. So this one, y equals negative 2x plus 8. Our gradient is this number in front of the x, negative 2. And the y-intercept equals positive 8. So we'll just write that as 8. And this last one, y equals 2.5x. So our gradient is 2.5. And the y-intercept, we've got nothing over here. So our y-intercept is at 0. Hope that makes sense. So these next 3 examples are essentially going in the reverse direction. So we start off with this information and then we write it out as an equation. So let's rub that out. So we're told that the gradient, I'll just write it as m equals 3, and the y-intercept equals 2. Equals 0. Gradient equals 1. Y-intercept equals 3. Okay, so I'll change back to red for these. Okay, so this first one, we're converting it, we're taking these numbers and we're converting it into this form. So this one, y equals this number in front of the x, 3x plus 2. So this is the equation that describes this. Okay, so this one, y equals, our gradient is negative 2. That's the number in front of the x. Y-intercept is 0, so it's essentially plus nothing, so I can just leave it like that. That's the equation. And this third example, y equals 1x, so I can just write that as x. And then plus 3. So that's just going the opposite direction to the examples we just saw. Okay, so we've got 2 more examples, and in these we are given the sketch of a line on the axes, and they want us to work out the equation. So let's just quickly recreate these. Negative 5, and the other one is that's 1, that's 3. Okay, so hopefully you can see that as we move in the positive x direction, this line is going up, so our gradient is positive. And because it goes up 5, it comes across 5 and up 5. So 5, don't get confused with this being negative. We're just going 5 positive steps this way in the positive direction, and 5 positive steps in that direction. So rise over run is 5 divided by 5, which equals 1. So our m in this case is 1, and the y-intercept, it's there, and it tells us that it's 5, so c equals 5. So the equation of this line, y equals 1x, so we'll just write it as x plus 5. So that means it has a positive slope of 1, and it crosses the y-intercept at 5. This one, because it's coming down, we need to go backwards one step, and then, so we go -1 in that direction, and then up 3 in that direction. So our gradient is rise is 3 over run -1. So this is -3. And our y-intercept is at 3. So the equation, y equals -3x plus 3. So every time we have a negative number in front of the x, it means the slope's coming down as we move in the positive x direction. And it cuts the y-axis at 3. Okay. That's where we'll leave this one. And hopefully that makes sense. I'm sure you've seen the equation of straight lines before. Yeah. Right, see you in the next video.